Hi, my name is Michael Buffalini, and I'm going to talk about permeability of source rock and extraction for utility scale natural gas. So what is permeability? Well, permeability is the rate of flow of a liquid or gas through a porous material. The permeability of source rock, such as shale gas, allows gas engineers to make accurate judgment on a theoretical amount of natural gas that can be obtained from a certain gas reservoir. The gas flow in porous media is usually pressure-driven volume flow and described by Darcy's law. Darcy's law at constant elevation is a simple proportional relationship between the instantaneous discharge rate through a porous medium, the viscosity of the fluid, and the pressure drop over a given distance. The behavior of fluid flow in porous media depends on the flowing fluid and the porous media properties as well as the flow characteristics. The permeability will dictate the factors involved in the job as well as the characteristics of material under consideration. The permeability of the source rock will determine fluid flow for waste runoff, which can be a useful factor to avoid unwanted, unforeseen accidents. The permeability of shale versus sandstone. This is a deeper explanation of how a coarser material would be better than something like shale, which is a smooth parallel surface. So typically we want coarse rock with bigger grains for pockets to store hydrocarbons, like the sandstone you see on the left. Shale has very close, smooth parallel plates of rock with very little gaps to create pockets to trap natural gas. Formations that transmit fluids readily, such as sandstones, are described as permeable and tend to have many large, well-connected pores. Now, the issue with having something like shale is that the confining pressure of the Earth's ground can close the fractures as well as reopen new paths during the hydraulic fracture or industrial fracturing project. And what this can do is can cause wells to close and reopen, but at the same time, we would want a consistent flowing well to extract the most amount of natural gas. Hydraulic fracturing for natural gas is something that's very important to be discussed because of the low permeability of the source rock or the shale. Fractures in the subsurface behave as major fluid pathways. Field and laboratory studies have suggested that the flow through a rock fractures differ significantly from that of smooth parallel plates due to the channeling flow and a heterogeneous aperture distribution generated by rough surfaces. So this is basically saying that we would prefer something like sandstone because the coarser materials allow for higher porosity to allow the fluid to flow through, where you can see on the left with the red lines, whereas the right formation shows the shale, which has little pockets of gas but not much of connection of the pores to allow the gas to flow out. So effective development of oil and gas fracture reservoirs require deep understanding of fracture flow characteristics, including the channeling flow in these reservoirs. Shale rock has a very low permeability because of this fact. Fracturing liquid is used to drill and strike the rock to create many extended fractures. The fracturing fluid usually contains sand, and what this does is it allows the fluid to evacuate the pores as well as keep the pores open longer for a longer lasting gas well. The permeability of shale rock has previously been a barrier and seen as a resource unavailable to us. From horizontal drilling and the discovery of fracturing fluid, the permeability of shale rock can be increased to obtain the natural gas for purposes such as electricity generation and manufacturing of goods. So you may say you still don't really believe why permeability is so important. Well, this is a very good example here. So many technologies to revert from the CO2 being emitted in the atmosphere and raising the greenhouse gases from releasing fossil fuels that have been stored under the Earth's surface for millions of years. Many people, like this plant here, has been using a treatment plant. This is actually in Algeria. To sequester the CO2 back into the ground in saline aquifers. So accurate predictions of fluid migration within the Earth crust is required for various engineering applications such as geologic disposal of high nuclear waste and oil and gas exploration. Carbon capture and sequestration relies on many technologies that have already been implemented at small scales by oil and gas industries for enhanced oil recovery and for CO2 disposal from natural gas refining. Deep saline aquifers are ideal candidates for storing CO2 because they can be found in diverse geologic locations, often have large storage capacity and ideal geologic properties, and are not used for drinking water sources. They are isolated from the biosphere. These aquifers have high temperature and high pressure, which is the reasoning for difficulty of experimental lab procedures. The permeability will dictate the factors involved in the job as well as the characteristics of the material under consideration. Permeability of the source rock will determine fluid flow for waste runoff, which can be a useful factor to avoid unwanted and unseen accidents. So in closing and final remarks, I hope that I have proved to you that permeability is a very important topic in today's society, especially for something as major as natural gas. Permeability dictates how well our fuel source can be obtained for heat and electricity and possibly our transportation, as here at Penn State with the CATA buses. It is an important matter that must be discussed considering it's our leading fuel of electricity. Although used all the time, hydraulic fracturing is still a newer concept and heavily relies on understanding how fractures behave and coincide with permeability.